Okay, so here's day two, integration, essentially. There are two integral rules. The first one is, since e of x is its own derivative, it's also its own integral, but don't forget this is indefinite, so we add c. But if I wanted to do b to the x dx, it would be b to the x over ln b plus c, plus c, because this would cancel off that natural log that we get multiplied by. So remember, the derivative of b to the x is ln b times b to the x. So this guy is a number, so I got to divide it out. Okay, so here we go. Most of these are a lot like the log derivatives, where it's really going to amount to like a substitution. So for instance, this first one here, integrate x squared e to the x cubed. Okay, hopefully you jump to going, let's make the exponent u. So set u equal to x cubed, du equals 3x squared dx. Okay, when I divide by x squared, or really maybe some of you guys have been making this jump, this x squared is going to cancel it off. But I'm going to have to do this as 1/3 du to get to dx. So it's 1/3 integral of e to the u du. Well, the integral of e to the x is e to the x, so this is just 1/3 e to the u plus c, because it is an indefinite integral. And then put x cubed back in for u. There we go. First one. Nice and easy. The next example, finding area under a curve. So let's take a look at that real quick. The graph is e to the negative 3x. So y equals e to the negative 3x. There we go. Let me zoom in a bit. So we're going to find the area between 0 and 1. So this shaded region here, around here. Let's see, this region. Yeah, so this region right here. That's kind of shaded. They've given us for approximation like 0.32. Probably can't. Yeah, it's right there, 0.32. So let's get that. All right, so it's all above the x-axis, so all I have to do is integrate from 0 to 1. Which we actually, to be honest, we've already integrated this guy. That was the last one. Oh, no, sorry, it wasn't that. Oh yeah, no, this is a little different. We're going to let u equal negative 3x this time. So if you want to, you could just plug this in. 0 in for that, it's going to give you 0. 1 in for that, it's going to give you negative 3. So we could redefine the bounds. Du is going to be negative 3 dx, which means negative 1/3 du equals dx. So I'm going to have a negative 1/3 out front, e to the u du. If that bugs you, this is less than this number, and we could just switch it then and make this positive 1/3. And now when I integrate this, e to the u is just going to simply be e to the u. Okay. So plug in 0. Well, that's going to be 1/3 e to the 0 minus, plug in negative 3 e to the negative 3rd. Well, this 1/3 times e to the 0, that's just 1. So it's 1/3 minus 1 over 3e cubed. And let's see what that guy is on the calculator. I bet it's 0.32. Otherwise, I did something wrong, and we'll have to try to figure that out. So 1 divided by 3 minus 1 divided by 3 times second e cubed. Oops. Delete. 0.3167374. Yep, there we go. 0.37 or 0.32. All right, next problem. Okay, an indefinite integral for x to the e plus e to the x. Now you might look at this one and go, oh, ugh, but don't worry, that's a number. This is the power. This is a good old power rule. Um, so we're going to keep the 0 and 1. This is just going to be x to the e plus 1 over e plus 1 plus integral of e to the x is e to the x from 0 to 1. Okay. So when I plug 1 in, I'm going to have 1 to the e plus 1. That's just 1 over e plus 1 plus e to the 1, which is e, minus x to the e plus 1, well, it's 0 over, which is, this is going to be 0 when I plug that guy in there. 0 to the e plus 1 is 0 over e plus 1, so simply 0 plus, and then e to the x is going to be actually e to the 0. Well, e to the 0 is also 1. Oh, sorry, ran out of space there, I didn't realize that. So 0 when I got plugged in 0, and then 1 when I plugged in 0 for that guy. So I really have then 1 over e plus 1 plus e minus 1. I don't even mess with making this common, just 1 over e plus 1 plus e minus 1. That's a fantastic answer. But actually it's pretty easy, again, pretty easy integral to knock out. Okay, another one, another integral. Again, just integral after integral after integral. If I'm looking at this problem here, before I do anything, since it's an e to the x function, it's 1 over that, I'm going to make this e to the negative pi x dx. Get it out of the denominator. Okay, and then I can let u be negative pi x. So du is just negative pi dx. And then, and then move this out front here. It's going to be du over negative pi equals dx. And even what I would do more so, because again, I don't want to mess with plugging pi x back in and all that junk. Plug 2 in for this and 0 in for this. I'm going to get, first of all, 1 over negative pi. And then I'm going to get 0 for the lower bound, because when I plug 0 in here, I'm going to get 0. And then when I plug 2 in, I'm going to get negative 2 pi e to the u du. If you don't like these guys, or, you know, this, make this 1 over pi, negative 2 pi, 0, e to the u du. And then this ends up just being 1 over pi e to the u from negative 2 pi to 0. When I plug 0 in, e to the 0 is going to be 1, so I'm going to get 1 over pi minus, when I plug negative 2 pi in, e to the negative 2 pi over pi. And, you know, we could just make this 1 minus e to the negative 2 pi over pi as our answer, because they do have a common denominator of pi. And again, crazy, weird, irrational number, but that's, again, it's just a matter of can you do the integral. All right. This one here is, it might seem like a weird indefinite integral. It's actually not that bad. The key is to expand this guy. So do FOIL. So e to the x plus e to the negative x times e to the x plus e to the negative x. And what happens is it makes this really easy then, because e to the x times e to the x is e to the 2x, because you add the exponents, x plus x is 2x. Then e to the x times e to the negative x, well, x plus negative x is 0, so I get e to the 0, which is really 1. Then I get e to the negative x times e to the x, that's also e to the 0, plus another 1. And e to the negative x times e to the negative x is e to the negative 2x dx. So what we really have then is integral of e to the 2x plus 2 plus e to the negative 2x dx. Now I'm hoping by now you're catching that, hey, this 2 would become a 2 in the front, so I need a 1/2 in front of that guy for 2x. Integral of 2 is 2x. And the same thing here, I just need now a negative 1/2 e to the negative 2x. And then plus c. Otherwise, just do each integral separately. This one you would e equal 2x, or sorry, u equal 2x. This one just is still 2x. This one you'd let u equal negative 2x. But again, hopefully you're catching on that, oh yeah, this would be a 2 that would come down to the front because the derivative of 2x is 2, so I need a 1/2 to cancel it out. There we go. So that's a lot easier if you end up expanding it. Otherwise, I don't even want to know what you have to do to that. All right, next problem. Integral of e to the tangent x times secant squared dx. Hopefully this is pretty obvious. Let u equal tangent x. du is secant squared x dx, and that's just going to cancel this guy off and this guy off. So integral e to the u du, and that's just going to be then e to the u plus c, and what was u? Tangent x. There we go. E to the tangent x plus c. It's getting quicker and quicker. This guy here, you've got e to the 1 over x squared. Okay. Now, again, you might be saying to yourself, how do I know what u is going to be? If, just making a guess. So we're going, well, I know I'll guess this because it's the exponent. That's true. That does work a lot of times. But the reason I know this is going to work is if I let u equal 1 over x, when I do the derivative of this, I get, this is really x to the negative 1. Okay. That becomes negative 1 x to the negative second du. Now it ends up happening, dx, not du. U ends up being negative 1 over x squared dx. Hey, there's that x squared in the denominator I need to get. So it cancels off. This negative will go out in front. What you can, so that gives you e to the u du. And again, what you can do is you can plug 1 in for x and 2 in for x. That gives us 1 down here, but 1/2 up there because it's 1 over 2 or 1 or 2 to the negative 1, which is 1/2. And if that really bugs you, switch the sign in the front and switch the bounds. I forgot to switch the sign, but I didn't switch the bounds. Okay. And now we get e to the 1 minus e to the 1/2 is our definite integral. And I plug 1 in for u, plug 1/2 in for u. Oh, so this is going to be e to the u from 1/2 to 1. Okay. All right, last example I want to do here then. I switched this because if we do the y-axis, we have to do something called the shell method, which we have not learned yet. So number 94, we're going to find the volume of the solid obtained by rotating about the x-axis, the region bounded by the curves y equals e to the negative x squared, y equals 0, x equals 0, x equals 1. So first, I will sketch this. You'll need to know what y equals e to the x squared looks like. So, you throw in your graphing calculator, or we throw it in this guy. Y equals e to the negative x squared. Okay, I don't need this anymore, this integral. So let's do y equals, well, actually that's nice because that integral there, actually that's the region for us. Here's x equals 0. Let me change the color of this, make it a little darker. Check properties, color, let's make it a nice red. Does that stand out better? No, not really. How about blue? Right now you're probably going, I don't really care. Let's turn how opaque it is down a little bit too. So that's actually our region. So the actual area of that guy is 0.75. But regardless, I went from x equals 0, x equals 1, and then y equals 0. So it actually would cut off this region. So what I'm going to do is I'm going to take that region and rotate it around the x-axis to find the volume. Okay. So and that's going to go again underneath here, kind of as the reflection. That volume. So this one's actually just kind of a nice straightforward pi from 0 to 1 of e to the negative x squared dx. Okay. Now, once we get this, then our function is actually negative 2x squared dx from 0 to 1. This one is a problem actually because we can't integrate by u substitution. So if we let u equal negative 2x squared, we're not going to cancel off that exponent. So this one would be one we'd want to plug into our calculator. I didn't do this one ahead of time, so I'll have to think on it. But for right now, I'm just going to say, hey, you guys weren't in class. Guess what? You get to use your calculator. So 0 to 1, second e to the negative 2x squared dx times, well, let's leave out the pi. Let's see if this, I know it's going to be a decimal, but maybe not. Maybe it's a nice value. Nope. 0.59814400067. So times pi 1.879 or something like that. Going to 3 decimal places. So there we go.